Welcome to another Achieving Science video. This video is going to look at changes in momentum. First of all, let's begin with the two factors that affect momentum. Momentum is affected by the mass and the velocity of an object. What's the connection? If we look at the equation for momentum, we see that momentum equals mass times velocity. Therefore, if an object has a greater mass, it's going to have a greater momentum. If it has a greater velocity, it's going to have a greater momentum. How then is the force calculated that causes a change in momentum? This introduces the equation force equals change in momentum divided by time taken. Let's have a look. If we look at a crumple zone, we can see the car has been in collision. We can see the front of the car has crumpled. This is its crumple zone. It is designed to squash upon impact. But why? Why is it not solid? Why is it not rigid? And therefore would mean that the car wouldn't need to be replaced. The reason is that it increases the time taken for the car to come to a complete stop. But why is this beneficial? Why do that? The reasoning behind it, if we look at the equation, there are things to notice. A larger force means a faster change in momentum. If momentum changes very quickly, the force will be very large, and this is what's happening in a car crash. If we put this in another way, if we can increase this number here that we're dividing the change in momentum by, we would actually reduce the force acting. So actually, by increasing the time taken to come to a complete stop, you reduce the force acting. That's crucial. Let's look at some questions. Please feel free to pause the video in order to allow you to answer the questions first. A roller coaster consists of 5 cars, each with a mass of 250 kilograms. What is the total mass of the roller coaster? Part A then. It consists of 5 cars, each of 250 kilograms, then the combined mass is 1,250 kilograms. Part B. A force of 500 newtons is applied for 5 seconds to get it started. Calculate the change in momentum. As you can see, on the screen I have changed the previous equation and rearranged it to allow just change in momentum. So change in momentum equals force times by time. In this question we can see 500 newtons is our force, multiplied by the time of 5 seconds will give us the change of momentum, which is equal to 2,500 kilograms meters per second. Part C. To stop the roller coaster, the brakes are applied. A frictional force of 250 newtons is applied for 8 seconds. So again, we've got the force of 250 newtons. 8 seconds is the time. We can calculate the change of momentum simply by multiplying 250 by 8 to give us 2,000 kilograms meters per second. Another question. Calculate the momentum of a football that is kicked. The football has a mass of 350 grams and starts moving with a velocity of 10 meters per second. If we remind ourselves of momentum and the equation is mass times velocity. We have to be careful though, because when we use this equation, the mass always has to be in kilograms. The velocity always has to be in meters per second. In this question, part A, we can see that velocity is okay. It's already in meters per second. But we need to convert the mass. There are 1,000 grams in a kilogram, and therefore we can convert this easily into 0.350 kilograms. We then multiply this by 10 for its velocity. We can calculate the momentum as being 3.5 kilograms meters per second. Part B. The average force exerted on the football when the player was in contact with the ball for 0.8 seconds. So we need to calculate the force. Force equals change in momentum divided by time. Don't be tricked out in an exam because it hasn't given you the change in momentum. You've already calculated. You've already calculated in the previous question, so you know it is 3.5. So change in momentum divided by time. 3.5 divided by 0.08 will give you the force, which is 43.75 newtons, which could be rounded to 44 newtons. Now, as well as crumple zones, we have airbags and seat belts, and all of which are designed to increase the time it takes you to stop. and reduce the momentum upon the driver. Other ways and other places where we find this happening is, for instance, on play mats. So in play areas you will find squashy mats as opposed to a solid concrete floor. This is designed to increase the time taken to stop. Cycle helmets and crash helmets are not solid, they're not rigid, again to increase the time it takes you to stop, therefore reducing the effect of the forces. Let's go through some other questions then. Again, pause the video in order to allow you to answer them. A girl has a mass of 100 kilograms and runs for 45 meters per second and then stops in 20 seconds. What force is required to stop? To remind ourselves of the equation. And good routine is to write out what you know from the question. So you know the mass is 100 kilograms. You know the change in velocity changes from 45 to 0 because she comes to a stop. So the change in velocity is 45 meters per second. Symbol for change is a triangle. Finally, you know the time taken for the change was 20 seconds. Now you can input all the numbers into the equation because the change in momentum is mass times velocity, so that's 100 times by 45. Divide that by 20, and then you can calculate the force, which is 225 newtons. Don't forget the units of newtons because that potentially can get you an extra mark. Next question. Car has a mass of 1,000 kilograms and is travelling at 30 meters per second. The car makes an emergency stop in 3 seconds. What force is required to stop the car? Remind yourself of the equation. Write out what you know. Mass, 1,000 kilograms. Travelling at 30 makes an emergency stop. It comes to a standstill, so its change is 30 meters per second. It takes 3 seconds. Therefore, change in momentum is 1,000 times by 30. Time is 3 seconds, so we divide the change in momentum by time, and we get the answer of 10,000 newtons, which can be written as 10 kN, 10 kilonewtons. Finally, a bullet is fired from a gun with a force of 100 newtons applied for 0.06 seconds. The mass of the bullet is 55 grams. What is the speed that it leaves the gun? Mind yourself of the equation. Write out what you know. Force, 100 newtons. Time, 0.06 seconds. Mass, remember, mass should always be given in kilograms. So therefore the mass is 0.055 kilograms. Now let's work out the change of momentum first of all. This is calculated by the force times by time. So 100 times by 0.06. If you know the object's change of momentum, you know momentum is made up of mass times velocity. So you can divide this by the bullet's mass, which is 0.055. This will therefore leave you with the velocity of the bullet. This in this case is 109 meters per second.